So I'm Patrick Mechin from TECHWAY, a European company located in France, specialized in FPGA technology and data acquisition. So yesterday, I have presented the FPGA platform we're making and also the optical interfaces we are using with the new add-on of products which are able to operate at 25 gigs to serve the high-speed communication the high-speed communication needs of our markets. So today I wanted to give you a use case of how to use that technology to bridge market, to bridge the defense and the industrial market by delivering high-speed communication means to this marketplace and to this application. So what problem we are trying to solve here is, as many of us have mentioned during these 2 days, most of the applications today are requiring high-speed communication means, and we have put together our technology, our FPGA boards, and our optical devices to deliver a brand new ODI interface. So for ODI, it's something pretty new. It stands for Optical Data Interface. This initiative is driven by a consortium called AXI, which has been initiated by a company called Keysight. Samtec is part of it, as well as Xilinx and Intel. So the purpose of ODI, of this interface, is to provide to the community a new protocol that will allow not only embedded application, but also telecom application or test and measurement application to benefit from a standardized protocol to move high-speed data. In order to create an ODI link or an ODI port, you need two technology. Obviously, you need optical communication at high speed, high density to achieve the bandwidth, and you need the associated FPGA technology to drive these optical communication links. Hopefully, these are two technologies we do manage at TECHWAY, and that's how we came to the decision to invest into that new protocol. So again, you have here the reference of the AXI standard organization. You can have a look on their website to get more information. The purpose is to define, again, a high-speed interface that will deliver up to 20 gigabytes, giga-word. In fact, it should be a big B here, giga-word per second data bandwidth. It's optical, so the mean is to operate also over long distances. Because of its optical nature, the goal is to interoperate heterogeneous systems, and because Keysight is the driving partner here, it has been originally defined for the test and measurement industry. So the clever thing with ODI is the fact that it's defined on existing technology or existing standard. So if you want to build an ODI links, you don't need to reinvent your hardware. You can rely on existing hardware. So in order to operate one ODI port, you would need to have an optical connection with a minimum of 12 links, each link operating at 14 gig. This is for the physical layer. Then the protocol layer, the ODI committee has decided to pick up the interlaken standard, which is also something that already exists. The interlaken standard has been defined by Cisco, and I think by another company called Cortina System. It's a device-to-device protocol which is defined to maximize the data transfer in between devices using a big data path. And this interlaken standard is very well suited with FPGA technology, and you find it as part of the latest FPGA generation. So big FPGA like the UltraScale series from Xilinx will offer you an interlaken capability to develop data communication. And finally, the AXI committee decided to pick up the VIDA49 standard for data encoding. As you may recall, the VIDA49 is a standard that defines the data format mainly for SDR, software-defined radio application, and the associated recorder application. So everything you need to develop an ODI port already exists. So at TECHWay, because we are trying to deliver to the marketplace products that implement the functionality on sort of an affordable platform, we decided to add into the recipe the PCI SIG form factor, and as well as the FMC form factor, the Vita 57.4, together with, of course, the required technology defined by ODI, again, FPGA, interlaken, optical Firefly for optical, and all together, we have all the tools that we need to deliver to the community a PCI Express-based ODI interface, which will deliver the optical data port that new application may require. So in terms of how we do that, so we do that using, obviously, our product, and in particular, the new generation of product I have announced yesterday, which are all designed to operate at very high speed. The optical FMCs and the FPGA boards need to operate at least above 14 gig to operate the links. So that's what we are putting together to deliver our ODI link. If we consider that in order to build an ODI interface, you need the technology I have described to you, most of the company making FPGA boards, and especially VPX company make VPX system, are in capacity to build an ODI board. The value proposal that we bring here into the market is to make one using PCI Express form factor on PC, together with FMC, together with VIDA49, to deliver a cost-effective interface. Another value that we will bring that will enable us to do an ODI interface pretty easily is the fact that not only that we have been working with the member of this committee for years, like Xilinx and Samtec, and obviously the VIDA organization, we have also specialized our company in delivering high-speed serial communication on optical using other formats that are popular in our industry. We all know the serial FPDP, which is a Vita 17.1 and 17.4 protocol, but also the ARANC 818 in the avionics sector, which is, again, another protocol using optical to move high-speed video. So all that knowledge together give us the capability to offer a cost-effective interface. In terms of optical, we're using Samtec technology. So the beauty with the Samtec Firefly is that by definition, It is a Firefly device, offers 12 links at 14 gig each. So by magic, it's exactly what is needed to implement an ODI port. So I believe this has been fully thought and done on purpose. But you take a Firefly device and you have a ready-to-go solution to implement an ODI port. So, and Samtec, as you know, deliver the chip, the technology together with all the cabling connection which are required. So this is how it's work, and in terms of wrap-up, I wanted to share with you the following points. So very soon we will launch, we still have a couple of months to go, but we will launch an ODI PCI Express interface, which doesn't deliver the full speed of an ODI port. This is really the TECHWAY contribution to the market. As I mentioned before, a full speed ODI port will deliver 20 gig. That's the spec. Our boards, we are using the Pareto rule, you know, our board will deliver only, if I may say so, 16 gig, which is 80% of the maximum speed, but for maybe the twice of the cost of a full speed system. So we hope by putting this facility on the market, we will help the community in the test and measurement industry, which is industry related, of course, but also in the embedded industry to adopt this protocol and get more application onto it. So thank you for your attention, and if you have questions,